Oh great, we're going to continue our discussion of solving equations with scary numbers. This time they're actually going to be kind of scary, so if you could just stay with me. The fraction part starts off a little scary, and then if you give me a chance, I'll show you a technique where you can get rid of all the fractions and then you don't have to worry about them. The decimals themselves, they're not too bad at all. So by the end of today, I'll be able to use my algebraic solving skills to find the solution to equations that have fractions or decimals. Before we do that though, we should probably warm up with something, so let's get our brains in gear. So let's take a quick look here. I'm going to use purple for this today. I want to solve, so I'm going to use my SAMDEB. So I'm going to go after the subtracting of 5 first. So I'm going to add 5 to both sides first. So then my new expression becomes, these guys would cancel. 9 plus 5 is 14. I'm going to divide both sides by -2 because that's how I undo this multiplication of -2. So keep in mind that's a dividing situation there, not an adding of 2 situation. Okay, and then these guys cancel for 1, and I'm left with x equals -7. And there's my warm-up question. So let's get on with it. Okay, so just a reminder, the goal of solving is we're going to use opposite operations, and we're going to try and isolate. That's the key word. We want to isolate the variable. We want to get a 1 in front, and we want it in the top position. Okay, so don't let the fractions and the other things scare you away today. All right, so this has a fraction in it. It's not that overwhelming of a fraction, but this is technically a fraction, so we're going to go through this problem just to get warmed up. And we're going to start with going after that 7. So let's subtract 7 from both sides. Those cancel. I'm left with x over 4 equals -12. Now the opposite of multiplying by 4, sorry, the opposite of dividing by 4 is multiplying by 4. So those would cancel, and x would equal -48. There, you did your first fraction problem. No worries. Okay, now don't panic. Here we go. So we have the same fraction problem twice. I'm going to show you two ways. The first method is going to be the one that's going to be a little bit uncomfortable for you. The second method, hopefully you'll see how slick and fast it is, and it's my preferred method. So if we look at this question here on the left-hand side, I'm going to use all of my same strategies. I want to get the x by itself, so I'm going to subtract a half from both sides. It's just a number, so it cancels. So now I'm left with x over 3 equals 5/6 minus a half. But I'm going to do a little changing as I go here. I'm going to just rewrite this as 5/6 minus 3/6. So I'm using an equivalent fraction right here. Okay, so now I have x over 3 equals, now for adding, subtracting fractions, remember just the numerators work together. The denominators do not get touched. So this is 5 minus 3, or 2/6. Okay, now this is getting a little bit smaller, which is my goal. You'll notice all of these equations start to get smaller as we do more work on them. So my last step to get the x by itself, because that's my goal, is I'm going to, let's do it in red so we can see it. I'm going to multiply both sides by 3. Okay, so this 3 and this 3 cancel, and what I see is that x equals, now if you can't remember how to multiply fractions, that's okay. I'm going to put a placeholder in here just so we can see, and if you remember, we multiply across the top and across the bottom, and that's how we can do a quick multiplication of our fractions, which is 6 over 6 or 1. Okay, so after all that scariness, the answer was actually pretty straightforward. It was just a 1. Okay, now here's my preferred method. I think this is a method you will like. It gets rid of fractions pretty quickly. You do have to do one specific action first just to free the fractions though. So when I look at this question, I want to see the denominators are 3, 2, and 6. So the lowest common denominator that they would all share is 6. Now I could do this with other numbers, but it's usually easiest with the lowest common denominator. But I want to find a number that 3, 2, and 6 all have in common. And the reason is I'm going to multiply both sides by 6. Okay, and because I'm doing the exact same operation to both sides, I'm maintaining my equivalence, so I haven't changed the expression, I've just changed the appearance. Now what's really nice about that is when I do that, then I can distribute. Okay, and when I distribute that 6 to both of those terms, I end up with 6x over 3 plus 6 over 2 equals, and I'm going to write it this way for now, but some of you will see a shortcut really quickly, I'm sure. And you say, hey, but hey, Mr. Childs, you didn't get rid of any of the fractions. What's the point of this? And I say, well, let's look a little closer. 6 divided by 3 on this term right here, well, that's a 2x. 6 over 2, that becomes a 3. And 30 divided by 6, that becomes a 5. Okay, so for those of you who noticed, we could have actually just canceled these up here and gotten straight to the 5, but I just wanted to show you how this worked. And you can see, hey, no more fractions. So from there, we can, but use a different color so we can see it a little easier. We'll subtract the 3, those will cancel, and then we're left with 2x equals 2. Divide both sides. Better give myself a little space here. Divide both sides by 2, and I'm left with, oh, big surprise, x equals 1. Okay, so now that you've seen it once, why don't you pause it here and try that, and we'll see how well you do. Okay, I'll just keep going then. And so now the first one, I'm going to subtract 7/10 from both sides. It's a completely okay move. I'm allowed to do that. So in my next line will have x over 5 equals, now I'm going to do a little switch as I go here. I'm going to get my common denominator. Okay, so the 3 became 30 over 10, and I'm doing that just to save some lines. I know where I'm going with this problem, so that's where I can save a little time and energy. 30 minus 7, there's 23 tenths. And then lastly, I want to get rid of this dividing by 5, so I'm going to multiply both sides by 5. Okay, and these guys will cancel. So now I can either do 23 times 5, that's one option. That makes a large number, so I can go 23, that's 115 over 10. Okay, or some of you might even notice that I can cancel the 5 and the 10 and reduce that, so that I would have a 23 over 2. That's another option if you're comfortable with doing that. Either way, you end up with x equals 11 and a half. Okay, now if we come over to the other technique where I'm going to try and get rid of all the fractions at one shot, I need the denominator, our common denominator here. I'm going to try and find the lowest one just to keep the numbers smallest. So my lowest common denominator here is a 10. So I'm going to multiply both sides, and please note I write my 10 in the numerator position. I don't want it drifting down at the bottom. I'm going to then distribute. Okay, so now I end up with 10x over 5 plus 70 over 10 equals 30. Okay, and I'm putting in that step as a thinking step. I could then do the division and say, hey, look, 10 divided by 5 is actually just a 2x. 70 divided by 10 is just a 7. And the 30 is left alone. From there, we're back to SAMDEB, subtracting 7 from both sides. So now I have 2x, these guys have canceled, equals 23, and then we divide both sides by 2. Try to squish it in here to make sure it all fits. X equals 11 and 1/2. Okay, so I got the exact same answer again. No surprise there. Okay, now these ones here are a little trickier. I've set them up to try and do them two different ways, but I think I'm just going to do one for the interest of speed. So I think I will get rid of this guy. I'll get rid of that too, and we'll just do this with one technique. So I'm going to look at this one here, and I'm looking at the common denominator, the lowest common denominator that's shared by 4 and 3 is 12. So the part that gets people in this is that the top parts don't have any brackets or anything on them, and there's an unwritten bracket there. So what I always do when I see these is I put brackets on them. Okay, and it's one of those silly things, you just wish people wouldn't do it, but for whatever reason it shows up in books that way. So we're going to add some brackets just to sort of keep track of this. Okay, so now I want to multiply both sides by 12. Okay, and now I could distribute the 12. I could do this. that is one option, and I would end up with 12x plus 72, and all that would be divided by 4, and it would start to get a little bit messy. So what I would prefer to do, though, and this is a bit sophisticated and it'll take some time to get used to, is I want to just deal with these guys. Okay, so what's 12 divided by 4? Well, that becomes a 3. Okay, and then I'll do the same thing on this side. What's 12 divided by 3? Well, that's a 4. Okay, now you'll notice my fractions are gone. And now I could do a distributive property where I multiply this in. And yes, I can multiply this direction. That's okay. And now I end up with 3x plus 18 equals 4 plus 4x. And now you can see we're already back to that 2 or 3 step problem where I have to get all of my like terms on one side. I'm going to subtract 3x from both sides because that's going to reduce my x's really quickly. And then I'm going to subtract 4 from both sides. And then my final answer, these guys have canceled, would be x equals 14. And yes, I can have my x on the right hand side. It's totally acceptable. It is still correct. Okay, we're almost done. Ooh, decimals. Okay, so let's not panic. Decimals are just numbers. All of the strategies we've been using still work. So my goal is to get this guy right here by itself. So I am going to subtract 1.8 from both sides. Okay, so those guys cancel, just like that. So now I have 0.5x equals, oh boy, better think this one through for a minute. So negative 4.8 subtracting 1.8 from it, and that's going to be negative 6.4. Oop, not 6.4, silly me. Where's my eraser? That is 6.6. Better get that right. 6.5. Oh, it must be late at night here. Can't think about silly things like this. 6.6. Okay. Shouldn't do these things too late at night. Makes silly mistakes. Okay, now, if I want to get rid of this 0.5 here, okay, it's just a number. So I'm going to divide both sides by, oops, give me a red here. Divide both sides by 0.5. Okay, so now I'm going to try and figure out how many 0.5s fit in that. And if I have to, I'll grab my calculator if it's great late at night, or kind of hoping I can figure this one out on my own and say it's 13.2. Okay, and it doesn't hurt to double check that, so take your time and do that. Convince yourself that it's right, and yay, it is. Okay, and let's do one more decimal. Oops, what did I do? I jumped up the page. Let's go this way. And here's our last decimal. Okay, and ooh, that looks really scary, but they're just numbers, so don't let it overwhelm you. Let's go after the x's first. So I'm going to subtract 2.4 from both sides. Finish the 4. Okay, so this becomes 1.2x plus 5.6 equals negative 8.8. Okay, because these guys canceled themselves off. Now I'm going to subtract 5.6 from both sides. Okay, these guys will cancel each other off. And you'll notice my problem is kind of getting smaller and smaller and smaller. And I don't have any faith in my mental math at the moment because it's late at night. So I'm going to just trust my calculator for a minute. That's negative 14.4. Fantastic. And then I'm going to divide that by 1.2. Okay, so I'm going to divide both sides by 1.2. And I should come up with, yay, look at that, a nice negative 12. So after all that scariness, we actually got a really nice answer. All right, so there's a couple questions to try. Give it a whirl. Thanks again for tuning in. See you tomorrow.